Good morning, friends and dear student. It gives me immense pleasure to be here again for my course, Flight Mechanics. This course belongs to the 4th semester in the Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad, India. I am Dr. Yagya Dutta Dwivedhi, Professor from the Institute of Aeronautical Engineering, Hyderabad. Today's I am in the second definition and the terminology of the cruise performance. Before I go for the cruise performance definition, we should know what is the cruise performance. Cruise performance is one of the most easiest flight in which your aircraft, first it is on the runway, it is going like this, then it is climbing. After reaching to the specific height, it will go a very long distance. In this case, lift is equal to weight, thrust is equal to drag. So the vertical forces will be balanced and the horizontal forces will be also balanced. Like these equations of motion where L is equal to W and thrust is equal to drag. This type of motion is called the cruise flight. We are going to discuss some definitions and the terminology depending upon the cruise performance. So in today's topic, we are going to discuss the range and endurance, thrust required, power required, define stall speed, define drag polar, and so on. We will be handling. So this is the definition and the terminology for the module 2. So what is the range? You know that every aircraft, if you ask the designer or if you ask any this bike or the car, everybody will see that by the given amount of fuel in my tank, how many long distance I can travel. That distance by the given amount of fuel is called the range of that vehicle. But if you talk about the aircraft, same way, aircraft is also having the fuel inside the tank. These fuels are used to go from one airport to another airport. The range of the aircraft is decided by the per second how much fuel is consumed. If you want to fly the aircraft for a long distance, we should not go very high speed or the very low speed. We have to fly the aircraft at a speed in which drag is the minimum. That is called the minimum drag speed. Every pilot, when it is flying in the aircraft, they will go at a certain height. There, the density is very favorable and the speed of the aircraft will be in such a way that it is generating the minimum drag. That speed the pilot has to fly, then it will cover the maximum range. So, I will discuss about the range, the maximum distance traveled by an airplane in a given full fuel capacity. If your aircraft is full fuel, how much distance it can travel, that is the definition of the range. Another very important definition is endurance. So this range is the distance, but endurance is not the distance, how much time it can fly. So if you want to go a very long distance, you have to define the range. But if you want to fly in a certain location and how much time it can float on the air. Like if you want to fly the aircraft for the surveillance and the reconnaissance purpose, our objective is not the range. Our objective is how much time it is flying on the air by the given amount of fuel. So we will be discussing about the endurance. So endurance is the maximum time sustained in an air by an aircraft in a given full capacity. If your fuel is full, how much time your aircraft can sustain in a air. Define the thrust. We have done already. Thrust is the force produced by the engine to counter the airplane drag. Define the cruise. Here it is, cruise is the flight phase that occurs when the aircraft levels after a climb to a set altitude and before it begins to descend. Cruising usually consumes the majority of the flight time, and it may include changes in heading, direction of flight at a constant airspeed and the altitude. So cruising means initially your aircraft will take off from the runway like this, then it will climb. After reaching certain height, it will maintain a constant speed. In that speed is the minimum drag speed. In that, aircraft will start moving, and the maximum of the time is used for this cruise flight. For the passenger aircraft, for the general aviation aircraft, cruise flight is used much more time. However, for the defense, for the fighter aircrafts, cruise is not very important. Other performance are very important. So till the time it is in the same height, altitude and the same speed, and it is not descending or ascending, that is called the cruise speed or the cruise of the flight. Cruise ceiling. The cruise ceiling, on the other hand, is the altitude at which the maximum climb rate is 300 feet per minute. So every aircraft has got a certain altitude at which it can go. If it is near the sea level or up to some height, aircraft will perform very nicely. As you go up and up, the rate of climb will be reduced. So the cruise ceiling is the altitude at which the maximum climb rate is 300 feet per minute or 15 meter per second. Then service ceiling. The service ceiling is the altitude at which the aircraft is unable to climb at a rate greater than 100 feet per minute. So if you see in this cruise ceiling, it is 300 feet per minute, but the service ceiling only 100 feet per minute. That is the 5 meter per second. So that is the service ceiling. This is the absolute ceiling, means beyond that even 1 inch aircraft cannot climb. So zero rate of climb, 0 feet per minute, that is called the absolute ceiling. The service ceiling is the altitude at which the aircraft is unable to climb at a rate greater than 0. It is not service ceiling, it is a absolute. Absolute ceiling is the altitude at which the aircraft is unable to climb at a rate greater than 0 feet per minute. Means 0 feet per minute, it is called absolute ceiling. Define the glide distance. So how much your aircraft can glide if the engine is failed? How much range it can cover when aircraft engine is failed? So if your aircraft is here and this is the range or the glide distance if engine is failed. So the distance traveled by the airplane when engine is cut off. So if the engine is failed or it is intentionally cut off for the practice, how much this distance, the horizontal distance, it is called the glide distance. Now define the density altitude. The density altitude is the altitude relative to standard atmosphere condition at which the air density would be equal to the indicated air density at the place of observation. In other words, the density altitude is the air density given as a height above mean sea level. So it is the density altitude is the air density given at a height above the mean sea level. So at the means, if you go above the mean sea level, whatever the altitude, whatever in that altitude you have the density, that is known as the density altitude. Define the VS. It is a stall speed. Stall speed or the minimum is flight steady speed of which aircraft is still controllable. It is a minimum speed in which aircraft can fly. VSO is a stall speed or the minimum flight speed in landing configuration. Then stall speed or the minimum stall speed for which the aircraft is still a specific configuration. Define the drag polar. The drag polar is the relationship between the lift of an aircraft and its drag, expressed in terms of the dependence of the drag coefficient on the lift coefficient. So CD is equal to CD naught plus KCL square. This is the drag polar equation. Define the thrust available. Thrust available denoted by TA is the thrust provided by the power plant of the engine. So how much engine can produce thrust? That is thrust available. Define the thrust required. The thrust required means it is dependent upon the drag. How much drag your aircraft has got. That is called the thrust required. The force which is used to counter only the drag is called the thrust required. The rate at which a given source will deliver energy to a load having an impedance that is conjugate of the source impedance to design as the available power of the source. So this is not correct. So it is the retarding force. It is the thrust to counter the drag of aircraft. This is the definition. This is not the correct definition. Define power available. You know, just like a thrust available, if it is a propeller aircraft, we always take as a power available. So the rate at which a given source would deliver an energy to the having an impedance of that conjugate is called the. So this is the power produced by the power plant. This will be greater than PR. Define power required. Power required is the power or the thrust that is needed to maintain unaccelerated flight for a given set of conditions, that is constant speed and in level flight, climbing, descending, turning, or any combination of these events. Define the maximum range. The maximum distance that the aircraft can fly is then equal to the ground speed times the maximum time T max. We call this distance the maximum range of the aircraft. Define maximum endurance. The maximum endurance condition would be obtained at the point of the minimum power required, since this would require the lowest fuel flow to keep the airplane in steady level flight. Maximum velocity of the airplane. In steady level flight, the maximum velocity of the airplane is determined by the high speed intersection of the thrust required and the thrust available. So I will just draw one diagram, and then this is the thrust required, this is the velocity, and I will draw the thrust available. This is the TA and this is the TR. This red color, this is the TR, means thrust required, and this is the thrust available. Thrust available means how much engine is able to produce maximum thrust. So at this point where both are intersecting, this point, this is the velocity, this is the maximum V max. Your aircraft will not go more than this, because after this, if you give the throttle also, aircraft will not accelerate. So this is the V maximum or the maximum velocity of the aircraft. So in steady level flight, the maximum velocity of an airplane is determined by the high speed intersection of the thrust required, this one, and the thrust available. So wherever both are intersecting, that is called the maximum velocity of the aircraft. Minimum drag speed. So the minimum drag occurs when the drag divided by lift is a minimum, or L by D is a minimum, or inversely when the lift divided by drag is a maximum. So minimum drag occurs when L by D is maximum. So if I draw the plot, L by D versus alpha, this is the L by D max. Okay, so if you fly in this speed, this is the V minimum drag. If this is the V, then this is the minimum drag. So you have to fly your aircraft in this drag so that your L by D will be maximum. So here we can, if it is the T and D, thrust required and the drag, and this is the velocity. So here is a V maximum here, and this is the V minimum. It is a stall speed here, this is the stall speed, and this is the V max. In the next lecture, I am going to discuss about definition and the terminology of the climb performance, and we will be discussing in my next lecture this topic. And we have the references: Anderson J.D. Jr., Aircraft Performance and Design, International Edition, McGraw-Hill's first edition, 1999. SL by ME, Aircraft Performance, Theory and Practice, AIA Education Series, AIA 2. Any questions, you are welcome to ask to me, Yagya Dwivedhi @gmail.com. Please do like and subscribe. And if you feel that there is some mistake, please do comment or do write mail in this given. I will try to rectify, I will try to correct this thing. Till then, goodbye and thank you.
Like, share and subscribe. Hit the bell icon for more updates.